Alright, so in this video we go over section 6.1, which is rational functions and multiplying and dividing rational expressions. So in this section we are going to define what a rational expression is, or rational function, and then we're going to do some operations, which is multiplying and dividing rational expressions. Alright, so let's start by defining what a rational expression is. So rational expression, well, as opposed to many other functions or expressions, in this case is one of those that is undefined for values of the variable that make the denominator a zero. Alright, so as opposed to polynomials, for example, you can have a polynomial like x squared plus 5x minus 3. You can plug in pretty much any number. The domain is negative infinity to positive infinity. You know, nothing makes a denominator zero. Also, but in this case, for functions like this, you'll see in the examples how this type of functions or expressions can be undefined for certain values. And to find those values of the domain, to find those values, or find the domain rather, what we do is set the denominator, only the denominator, equal to 0 and solve the resulting equation. The values found in the previous equation are the numbers that get excluded, from the domain. Okay, so sometimes we refer to those numbers as the restricted values or illegal numbers. Okay, alright, so let's find the domain of this rational function. Notice in this case, if you observe this function, we cannot just plug in any single value of x, you know, like x equals 1, well, that's going to work, but x equals, let's see, what are we going to do here? We're going to focus on the denominator only. So I'm going to highlight the denominator, set it equal to 0, and we'll solve the baby equation by adding 3 to both sides. X equals to 3. This means that this is the number that gets excluded from the domain. So in other words, what happens if you evaluate f of 3? Well, 4 times 3 squared minus 7 divided by 3 minus 3. Well, 3 squared, that's a 9 times 4, that's 36 minus 7, and 3 minus 3 equals 0, which is 29 over 0. So plugging in x equals to 3 will give rise to a 0 in the denominator. And when we get a 0 in the denominator, this gets undefined. So we're looking for those numbers. So in this case, this is a restricted value, or this is also an illegal number. So how do we represent this? So in this case, we need to use the set builder notation, x such that x cannot be 3. So we are excluding it by saying x cannot be 3, because see what happens? It gets undefined. Alright, so let's look at another example. Example B. Well, highlight the denominator, x squared plus 5x plus 4, and set it equal to 0. So x squared plus 5x plus 4, double bubble lid in this case because the leading coefficient is 1, so this one is going to be easily factorable by double bubbling it. So factors of 4 that add up to 5 plus 4 and plus 1. 4 times 1 is 4, 4 plus 1 is 5. And in this case, well, setting this x plus 4 equal to 0 and x plus 1 equals to 0. And again, of course, if you want to keep highlighting this the same way I did it in the previous chapter, of course, feel free to do that. This way, it's going to help you out. So subtract 4 to both sides, or subtract. And this is x equals negative 4, one of the solutions. Over here, subtract 1, x equals to negative 1. Pretty simple. Now, how do we express this in set builder notation? So x such that x cannot be negative 4 and x cannot be 1. Alright, well, to further explain what about the domain of a function, how does that work in certain situations? Well, so let me give you another example. And you might want to go back to the usual perspective of what a function is. A function ultimately is a machine. So input, function, output. Okay, so in the previous chapters when we briefly introduced functions, we consider the cases in which we don't have any restrictions for certain functions just the same way as opposed to in this case we have over here some of them. So for example, let's see, suppose this machine is I don't know, let's see, coffee machine. Let's think of this as a coffee machine. Let's list, doesn't matter the output for now. What we care about is OK inputs and not OK inputs. Okay, so to a coffee machine, what can we add to a coffee machine? Well, number one, we can add water. All right, we can add water to the coffee machine. Well, what else? Well, coffee beans or ground coffee. Well, what else can we do? Well, I like adding some cinnamon to, I think it's double N, cinnamon to the coffee. It tastes really good. Sometimes a little bit of vanilla vines here. It's good. So far, or we can just put all these ingredients in a coffee machine. You can add even more, to your coffee. Let's say you want to add even some liquor to it, like Kahlua. Right, Bailey's, I don't know. But the minute I put something like a baseball, is a baseball a good input, an okay input for a coffee machine? In this case, it's not an okay input. What's going to happen in this case? It's going to blow up. How about a rock? Can I add a rock to a coffee machine? It's going to blow up again. Can I add, I don't know, car oil? Well, not a good idea. So those are elements that we restrict from this function that are not okay inputs. So in this case, what's going to happen if I add a baseball or a rock or car oil to our coffee machine? The machine is going to blow up. Same here. For this function, if I add the number 3, see how I get this undefined? I get a 0 in the denominator, the function blows up. Here on the second example, if I plug in negative 4 over here, or if I plug in negative 1, these are the restricted values that I cannot add. Suppose you can think of this function of this coffee machine. This right here is the rock and maybe this is the baseball in which the machine is going to blow up. Right? Everything else, all single numbers, could be the water, could be the sugar, could be the cinnamon, etc. Okay. All right. So let's see. Let's work with simplifying rational expressions. Well, so steps to simplify a rational expression: completely factor the numerator and the denominator of the rational expression, and then number 2, divide out common factors that you see between them. Alright, so we are going to completely factor the numerator of this first example. So if you look at this, they have a 7 in common, and they have 1 power of x in common, leaving us with x plus 2. Now if I factor the 49x, in this case I can factor that as a 7 times 7x. And in this case we are going to divide out the common factors. Cancel the 7 with the 7, cancel the x with the x. That's going to leave us with x plus 2 in the numerator and 1 7 in the denominator. Alright, so let's see what do we do on the next one. So for the next one, letter B, 4x minus 20, factorize the numerator. In this case we can use the GCF. What they have in common is a 4, and leaving us with x minus 5. And then what we can do here is 6x minus 30, find the GCF as well. So it looks like 6 is part of the common factors, and then x, it's another part of the common factor, so that's going to give us x minus 5. Alright, so in this case we are going to cancel the whole thing, x minus 5 and x minus 5. That's going to leave us with 4 over 6x. But in this case, notice between 4 and 6 they have a 2 in common. 2 times 2, 2 times 3 times x. Don't forget the x. Cancel the 2's, and x, we're going to be left with 2 over 3x. Final answer to this. Okay, let's see final answer now. Let's look at the next example, letter C. So in this case we are going to bring back everything we learned in chapter, well, most of what we learned in chapter 5, which is factoring polynomials. So in this case we have a difference of squares. We have something squared minus something squared. That's going to factor as x plus 2 times x minus 2. And then in the denominator, it looks like this one is going to take a little bit of work because we have a trinomial whose leading coefficient is different than 1. In this case it's equal to 2. Okay, and it cannot be factored out. Alright, it cannot be factored out. So in this case, let me do that part of the work. At the bottom, use the bottom of the page. So I'm going to write the polynomial 2x squared minus 3x minus 14. 2 times negative 14, that's a negative 28. Then negative 3, bring it down here. So we look for factors of negative 24 that add up to negative 3. And in this case, I'm thinking of 7 and 4. Okay, so 7 in this case, well, that has to be the negative 1. So the sum of them is a negative number. Turn that into negative 7x. And turn down into 4x. So 2x squared minus 7x plus 4x minus 14. And in this case, well, use grouping to keep factor this polynomial. So x times 2x minus 7, and factor out between 4 and 14. I'm going to factor only a 2. I cannot factor the 4 because 14 doesn't divide into 4 evenly, so only 2 times 2x minus 7. See how these two are the same? So this will be 2x minus 7 times x plus 2. And I'm going to go back to the original expression to replace this guy, which is, let me highlight this one. This is really that in factored form. So this will be 2x minus 7 times x plus 2. And let's see, do we have any factors, any common factors to divide out? Well, let's find out. Here we have an x plus 2 and then another x plus 2. So let's continue. When we divide out these two, we're gonna be left with x minus 2 over 2x minus 7. Final answer. In this case, this is our final answer. We're done canceling common factors. Notice in this case, we do not cancel this x with that x, or with this 2 with that 2. All right. So maybe I should show you a very fun meme. What happens when you do that? So every time we cancel terms like this, a kitty dies. Okay, you don't want to kill kitties by canceling terms. What we do is divide out common factors, not terms. Okay, I'm gonna put it again just so you can see what happens every time one cancels terms. Okay, so this is not correct. Let's move on to the next example. This one, wow, this one is gonna be a very fun one to work with. Look at the numerator. All right, let's look at the numerator. And in the numerator, we have 4 terms. Let me write it down here. Okay, so a cubed plus 3a squared plus 2a plus 6. I'm going to factor this one using the, let me use a different color that gives us a good contrast. Okay, so in this case, I'm going to factor by grouping. Group these two, group those two. So factor out a squared, and we're left with a plus 3. Over here, if we factor the GCF, which is the 2, we're left with a plus 3. And then another GCF, a plus 3, a plus 3, and a squared plus 2. So I'm going to write this in the place of what we have for the numerator, that instead of a cubed plus 3a squared plus 2a plus 6, I'm going to write the factor form, which is a plus 3 times a squared plus 2. And then divide by the factoring of this trinomial, and in this case, it is the double bubble method what works. Factors of 9 that add up to 6 plus 3 and plus 3. Because 3 plus 3 equals 6 and 3 times 3 equals 9. Divide out, and then we're left with a squared plus 2 and over a plus 3. Alright, this is final answer. Alright, be careful, do not go any further than this. Do not do a squared over a to have an a, and plus 2 over 3. Okay, this is not how we cancel terms. What happens every time we cancel out terms? This is what happens. Right, a kitty dies. Okay, let's look at letter E. Okay, this one, again, you don't want to cancel out this like that and those like this. A kitty dies if you do that. So the way we have to treat this like is by factoring out the difference of squares, m minus n m plus n, or plus and then minus, doesn't matter, then m plus n. And in this case, m plus n cancels m plus n, leaving us with m minus n in the denominator. Final answer. Just as easy as that. Very short, very easy. This is E of easy. Alright. Letter F. Let's see. Very similar to letter E. However, number 1, P minus Q times P plus Q. Where am I getting this from? Well, this is a difference of squares. Just like m squared minus n squared, m minus n, m plus n, p squared minus q squared is the same, just change the letters. And then in this case, we can factor out the 5. Okay, so divide out p plus q, divide out p plus q. All we're left with is p minus q over 5. Final answer. Nothing else to keep simplifying. Alright, letter G. We have another difference of squares. X squared minus 49, that's an x minus 7 times x plus 7. That's how we factor this difference of squares. And you might want to rewrite this x minus 7 squared as x minus 7 times itself, x minus 7. Divide out, divide out. And then we're left with x plus 7 over x minus 7. And this is final answer. We don't do anything further. We don't cancel this x to get, and we don't cancel this 7 over 7 to get negative 1, for example. That's not how we do. Okay? This is okay answer. This is final answer. Otherwise, what happens if you divide, if you cancel out terms like this? A kitty dies every time you do that. Okay? And Math Excel is going to mark it wrong, of course. So two things are going to happen. All right? And be careful with letter H, because, I mean, if you look at letter H, it seems like we can divide out 2 over 2 and x over x to get 1. And yes, that is going to be the correct answer, but not using the correct method. So in this case, you might want to change the order of this. Like, instead of 2 plus x, make it look like x plus 2. It's the same. Now, the reason why we can cancel this is not by canceling x with x and 2 with 2. The reason is because of this. And I'm going to put this invisible ones. This is being multiplied by 1. And this is also being multiplied by 1. Alright, so we divide this out. Of course, you don't have to put these two, but I'm just explaining the reason behind we can cancel these two. So 1 over 1, final answer, equals 1. So this is not because x plus 2 over x plus 2, boom, boom, cancel, boom, boom, cancel. That equals 1. That's not the correct way to cancel this out. So even though you get the same answer, but it's not the correct method. And let me give you one of those examples in which correct answer but wrong method or wrong rationale. So if you think of this like let me give you an example that works perfectly for this. 16 over 64. What does that reduce to? Well, 16 goes into 64 4 times. That's 1/4. But in this case, can I cancel these two 6's? See how weird this is? All right? You still get the same answer, but this is not the correct way to think about it, right? This is weird, but still it's kind of cool at the same time. Right? It's weird and cool, but not correct. All right. Let me do the next one. Very similar to letter H, letter I. 2 minus x, x minus 2. So notice what I did on letter H. I made them look the same way. Right? And all we have to do for letter H is just reverse the order. For letter I, on the other hand, I'm going to do the same. I'm going to change the order. However, in this case, I would have to factor out a negative sign. If I factor out a negative sign, that changes the order x to x minus 2. Because negative times x is negative x, and negative times a negative 2, that's a positive 2. And in this case, we factor the whole thing, x minus 2 with x minus 2. And there is an invisible 1, an invisible 1, negative 1 over positive 1. That's negative 1. All right. Let's do another one, letter J. So for letter J, well, x minus 7, x squared minus 47. This is another weird one, another very, very weird one. What happens? Number one, well, difference of squares in the denominator. We already did this one in letter G. Let's just use the result, x minus 7, x plus 7. So all we do in this case is divide this out, the whole thing. And that's going to leave us with 1 over x plus 7. Final answer. This is the correct way to do it. The incorrect way to do this is by x minus 7 over x squared minus 49. All right. This x goes with 1, leaving us with negative 7 over negative 49. That's a 7 in the denominator. You know how we get, in a way, the same result, but the incorrect method, the incorrect way to think about it. You know what happens when you cancel out terms and not factors? A kitty dies every time you have to do that. All right, let's move on to the next example, multiplying rational expressions. So in this case, to multiply rational expressions, no, we are not going to FOIL all this. We're not, because if we do that, we're going to make the problem even harder than it is. Instead, do the opposite. Completely factor numerators and denominators, and then multiply numerators and denominators. Well, in a way, we are going to skip this step. I'll show you why. And then all we do is just simplify. I'm going to explain why we can omit. In a way, we can omit. I'll show you. Okay, multiply and simplify the result if possible. Well, so what we have to do in this case is factor out every single one of the numerators and denominators of each fraction. Well, x minus 3 is simply x minus 3 and cannot be factored into simplest terms. The number 5 is simply the number 5, but in this case 5x plus 35, that we can factor out the 5. And in the denominator, x squared minus 9, that's another difference of squares, x minus 3, and x plus 3. And in this case, well, the reason why I'm going to omit the multiplication is because from here, we can divide out x minus 3 and divide out the 5's, leaving us with x plus 7 in the numerator and x plus 3 in the denominator. And this is final answer. Don't you dare to cancel these x's. You know what happens when you cancel those x's. You know, a kitty dies every time we do that. Let's do part B. Part B, example B, well, Let's see if we can factor out this first numerator. Notice between 7 and 28, we can factor out the 7, y plus 4. In the denominator, well, we only have the 4y, it's simply 4y. Let's just leave it like that. In the numerator, oh, that's a times and not an equal, times. The number 8 can be divided with 4 if we go 4 times 2. And in this case, we have a trinomial whose leading coefficient is 1, so we can do the double bubble method. So let's double bubble this one. All right. That's negative 8, factors of negative 8 that add up to 2. So in this case, plus 4 and minus 2, because 4 times negative 2 is negative 8, and 4 minus 2 equals positive 2. And in this case, because we already have everything factored out, right? We have everything factored out, we are ready to divide out common factors. Cancel, 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 and I think that's about all we can divide out. So in this case, notice we are going to be left with 7 times 2. That 7 times 2 is going to be a 14. And in the denominator, we are going to be left with a y times y minus 2. And I know what you might be thinking here. I know what you might be asking yourself. Should we keep going, simplifying, distributing this y? The answer is no. Actually, if you do distribute the y, your answer won't be simplified. So the most simplified form is that of this form, which is in factor form. Okay, let's look at letter C. And yes, that letter C, oh, it's going to be interesting to do. It looks huge, but don't let it scare you. Ultimately, we are going to deal with one at a time. 1, 2, 3, and 4. Okay, I think the toughest of them, in a way the toughest, is going to be the one at the very top. I'm going to deal with this one separately. The other ones, if you observe, they are trinomials with leading coefficient 1. Again, can I divide out these x squares? These x squares, we cannot divide those x squares simply. What happens if you divide those x squares? A kitty dies. Okay. So we're gonna double bubble, double bubble, double bubble. Factors of 64 that add up to 16. Well, plus 8 and plus 8. Because 8 times 8 equals 64 and 8 plus 8 equals 16. Double bubble the numerator of the second fraction. Again, I'm going to deal with this one in a minute. And factors of 16 that add up to 10, I can think of x plus 8 and x plus 2, because 8 plus 2 equals 10 and 8 times 2 equals 16. And for the last one, factors of negative 10 that add up to negative 4, I'm thinking of negative 5 and 2. So in this case, well, because negative 5 times 2 equals negative 10 and negative 5 plus 2 equals negative 3. So let me double bubble this one in a minute. I'm going to work on this separately. I'm going to write 2x squared plus 12x minus 32. And you might be thinking, well, are we going to use the diamond method in this case? No, because the GCF in this case is the leading coefficient. The number 2, we can factor it out, as opposed to examples in which we won't be able to do that. We would require the actual diamond method. Plus 6x minus, in this case, 16. Okay. And we can double bubble this trinomial over here. 2 times double bubble. Factors of negative 16 that add up to 6, x plus 8, x minus 2. All right. And I'm going to bring everything down, all this, x plus 8 and x minus 2. But don't forget this factor of 2. All right. So now that we have everything ready to divide out common factors, x plus 8 with x plus 8 divide out. Another x plus 8 with x plus 8 divide out. What else do we have? Do we have anything else? Maybe x plus 2 with x plus 2. What are we going to be left with in this case? It looks like there's nothing else to divide out. We are left with 2 times x minus 2 and in the denominator we are only left with x minus 5. Alright, final answer. Again, can we cancel out these x's and call them a goodbye? We cannot. Kitty dies. Yep, the kitty dies every time we cancel out those x's. Alright, let's look at the next page. Let's see what about it. Another example, well, let's look at the numerator p squared minus 9. That factors has a very nice difference of squares, p minus 3 times p plus 3. Then divide this by the double bubble of, in this case, this denominator. Alright, factors of 6 that add up to 5, p plus 3, p plus 2. And then p plus 2, that's simply p plus 2. But in the denominator, be very careful. Look at the order of the terms. We always want the variables first and then the constant terms. Now we need to do the same here. We need to move this over here. So what I'm going to do, I'm going to factor the GCF along with the sign, in this case negative 2 times p plus 3. P in this case minus 3. P minus 3. Okay, so in this case we are all ready to divide out every single common divisor, common factors. So p minus 3 will go with p minus 3. P plus 3 goes away with p plus 3, and p plus 2, p plus 2. So ultimately, what are we going to be left with in the numerator? In the numerator, everything canceled out. Should I get a 0 in the numerator? No, not a 0. In this case, notice everything here has an invisible 1, so I'm going to be left with 1 in the numerator, and in the denominator, this negative 2. So 1 over negative 2, which equals a negative 1/2. Final answer. Okay. Let's look at the last topic for this section. Okay. So let's see. Dividing rational expressions. To divide a rational expression, number 1, multiply the dividend by the reciprocal of the divisor. So in this case, I'm going to show you a new rule. In other words, use the Kfc rule. What's the Kfc rule? Well, it doesn't have anything to do with chicken here, or wings, or potato wedges, or coleslaw, or what else do they have? Potato puree, so it doesn't have anything to do with that. I'll show you what this means. And then for step 2, proceed as a multiplying rational expression, which is basically repeat what we did here. Alright, divide and simplify the result if possible. So in this case we are going to apply the Kfc rule. So Kfc, what does that mean? K means keep, F means flip, and C means change. Okay, so what are we going to do in this case? Well, let me put it on Kfc. So we are going to keep the first fraction, leave it the way it is. Flip the second fraction, that is this one, flip it, reverse, put it upside down, or find the reciprocal, in other words. And so instead of having y squared minus 7y minus 18 over 4y plus 36, turn that into 4y plus 36. Divide by y squared minus 7y minus 18. And change the division into a multiplication. Essentially, this is what we have, right? Keep. Here is the keep. Flip and change the division into a multiplication. So that's the Kfc rule. Again, it doesn't have anything to do with chicken at all. And now we proceed as multiplying. So all we do is factor out everything in the numerators, the denominators, and then divide out common factors. So in this case, I'm going to double bubble this one, factors of -6 that add up to -1, -3, and +2. This is going to be a difference of squares, y minus 9, y plus 9. Times, factor out the 4 times y plus 9, because 4 times 9 equals 36. And then divide out by the double bubble of this. Factors of 18 that add up to 7, I'm thinking of -7 and +2. Because -9 times +2, -18, and -9 plus 2 equals -7. Now we're ready to divide out common factors such as, well, let's see. Y plus 2 goes away with y plus 2. And y plus 9 goes away with y plus 9. And looks like that's about it. Because in this case, well, there's no 1 minus 9 in the numerator, so I can cancel it out. Or another y minus 3 in the denominator, so I can also divide it out with that. So I'm going to be left with, in the numerator, only with y minus 3. And in the denominator, I'm going to be left with y minus 9, y minus 9. Alright, but in this case, we can rewrite this as follows. Y minus 3 divided by y minus 9 quantity squared. Actually, in this case, either of these two answers are correct. Okay? Either way. Alright. Let's move on to the next and last page of this. Alright. In this case, notice how the divisor, it's only one factor, so you might want to think of this as being a plus 2 divided by 1. This way we can use the Kfc rule. For the Kfc rule, keep the first fraction. Of course, if you feel comfortable with factoring as you go applying the Kfc rule, by all means, you can do that. However, I try to do one step at a time. That is, do the Kfc rule first and then factor out the polynomials. So I'm going to keep the first fraction, flip the second fraction, and change the division into multiplication. And we're ready to factor this out. Well, so in this case, trinomial, double bubble it. And a difference of squares in the denominator. So A and A and A. factors of 2 that add up to 3 plus 2 and plus 1. Because 2 times 1 equals 2 and 2 plus 1 equals 3. Difference of squares, we have done this one a few times, but with a different letter, plus 3 and minus 3. And then, well, in this case, there's nothing else to do. 1 is simply 1. A plus 2 is simply a plus 2. How lovely is it when you don't have to do anything over here? So all we do is just divide out, divide out. And in this case, well, we're going to be left with 1 times a plus 1, which is a plus 1, divided by a plus 3 times a minus 3. Of course, factoring out the difference of squares didn't really help at all. Didn't help at all to simplify this, but we still have to leave it like this in factor form. So it is considered correct. Okay. Final answer. All right. Letter C. Letter C, well, we're going to have fractions that are going to be a little bit ugly looking like this. So in this case, how do we proceed and work on this? Well, number one, you might want to group this. Put parentheses around, put parentheses around, put parentheses around, put parentheses around. Okay. So in this case, we are dividing one fraction by another fraction. So we are going to change the notation for this. So 12x over 5x plus 20. It's being divided by 4x squared over x squared minus 16. And now this looks like something you have done, that we have done before, So all we do is use the Kfc rule. So keep the first fraction, flip the second fraction, and change the division into a multiplication. And now let's go ahead and cancel, factor out first. Okay, I'm going to skip the first part of the numerator of the first fraction. I'm going to do that at the end. I'm going to focus on the denominator of the first fraction and the numerator of the second fraction. So I'm going to leave blank. I'm not going to write the 12x. I'm going to write something else. So here we can factor out a 5. And over here we have a difference of squares, x squared minus 16, that factors as x plus 4 and x minus 4. Alright, and over here I have 4x squared. Notice that 12 has in common 4 with this 4, so I'm going to write this 4 times 3x. So in this case, when you simplify this, x plus 4, these 4's go away, and in this case 1 power of x cancels with this x, leaving us in this case with 3 times x minus 4 divided by, in this case, 5. Out of the 2 powers of x, we cancel 1. We were left with 1x. In this case, 5x. Final answer. Alright, for letter D, I'm going to get you started with this one. So, y squared minus 9. The first fraction remains the same. Times the reciprocal of this one, which in this case is 2y squared plus y minus 10, and divide that by 3y squared plus 10 y plus 3. All right, so for the first part of the factoring, well, all we can immediately do in this case is the difference of squares. Y plus 3 times y minus 3. But for the other polynomials, we are going to be needing the diamond method for all the three. Okay, so in this case I will just give you the answers. Okay, this will turn. Okay, let me highlight this. Let me highlight this one with blue. Okay, I'm gonna highlight this with blue just so you can see where is everything coming from. So in this case, this will turn into 2y plus 5 times y minus 3. Okay, this one right here that I'm going to highlight with this, with orange, that's going to become 2y plus 5 times y minus 2. And last but not least, I'm going to highlight this one with pink. This is 3y plus 1, y plus 3. So let me just write a note below. The polynomials, or the, well, actually the trinomials, highlighted in orange, blue, pink, are factored using the diamond method. Okay, so these are factored using the diamond method. Okay, let me highlight that part. Using the diamond method. The thing is, I'm just going to give you the answers to this, because otherwise the video is going to take too long for me to do all this factoring using the diamond method. Of course, feel free to verify those results on your leisure time. Of course, set this one, do the diamond method to get this. Do the diamond method on the orange one to get that. Do the diamond method on the pink one to get that. And then we are just going to divide out all the common factors in this case. We have a y plus 3 times y plus 3. That is going to go away. We have another... Do we have another... Oh, wait a minute. Yes, that's a y plus 3. Then we have a y minus 3, canceling out this y minus 3. Then we have 2y plus 5, 2y plus 5, and that's about it. That's about canceling all common factors, so we are going to be left with y plus 2 in the numerator and 3y plus 1 in the denominator. Final answer. Okay, and this is the end of this video, so it's a good place to quit. I'll see you on the next video. All right.